For homework, first I want you to look at the homework 1 module, and there I want you to implement a Mary era style monetary policy, minting policy. In Mary, it was already possible to use native tokens, even though Plutus didn't exist, and you also could use minting policies, but only of a relatively simple type. And what you can do is you can specify signatures that have to be present in the minting transaction, and you can specify deadlines. So you can say that minting must not happen after the deadline has passed. And there's more you can do. You can also combine several such policies with logical AND or OR. What I want you to do here in the homework is to implement a minting policy that has two parameters, a pub key hash and a POSIX time. And the idea is that minting should only succeed if the transaction is signed by the corresponding signature and if the deadline has not yet passed. Then you have to implement the depending things like the policy and currency symbol accordingly. Now for the off-chain code, I already implemented that. So as parameters for minting, you must provide the token name, the deadline, and the amount you want to mint. And then in the mint contract, I first look up my own public key hash, as I explained before. Then I use current time to look up, as the name suggests, the current POSIX time. I look up the deadline from the parameters. And if the deadline has already passed, then I just log an error message. So I don't even bother submitting a transaction because I know it will fail anyway during validation. However, if the deadline has not yet been passed, I compute the value I want to mint, so just using the currency symbol, the token name, and the amount. Then in the lookups, I must specify the minting policy. And finally, in transaction, I need two constraints that I combine, so that I want to mint the value in this transaction and the validity interval. And this is a bit tricky. I mean, the natural choice probably would be to use toDeadline. So the interval as large as possible, and seeing as now is before the deadline, now should be in that interval, and that should be fine, and it should pass validation. However, there is this issue that the underlying blockchain, the Cardano node, doesn't work with POSIX time, it works with slots. So conversions happen. And now it unfortunately could happen if I use toDeadline, that then gets translated to a slot, and then when Plutus actually validates it, it gets converted back to POSIX time, and we can end up with a different POSIX time with, if we are unlucky, depending on where the deadline sits in respect to the slots. Does it sit at the beginning of the slot, in the middle, at an end? It could happen that we end up with a time that's actually past the deadline. Furthermore, there is the issue that you are not allowed to pick validity intervals with a specific upper end that lies too far in the future, because this conversion only works if we know the slot length, and the slot length could be changed with a parameter update, and we can't be sure when that will happen in the future. So we can only look so far ahead. I don't know the precise horizon, but it's certainly less than months or years. Of course, in this case, if you mint tokens, probably the deadline won't be that far in the future. But nevertheless, I decided to use 2 now plus 1 minute. So that means as long as this transaction ends up on the blockchain in at most a minute, and as long as the deadline is further than a minute away, this should be fine. So now, of course, it could happen that even though the deadline has not been reached, we're relatively close to the deadline, let's say only half a minute or so before the deadline, and then the check here, the check would pass, so, or fail rather, so we would end up in the else block, but this 2 now plus 1 minute would then end up to be past the deadline, and then we would try to submit a transaction and it would fail. So it's not clear to me what the best possible choice here is. But as long as the deadline is comfortably far away, like more than a minute, this should be fine. Okay, then I submit the transaction, wait for confirmation, log a message. Then I define the endpoints in the usual way and do the boilerplate for the playground. And then I write a test emulator trace. So as token name, I again pick ABC. And as deadline this time, I mean, normally for emulator traces, I always use like a few slots only, unrealistically few, because then the simulation is faster. But now, because here I have this +1 minute, which is 60 slots, I decided to use somewhat bigger values. So I, as deadline, picked 100 slots. So that's like 1.5 minutes. So I start the endpoint for wallet 1 and call mint. And I wait 110 slots, so now the deadline should have passed, and I call mint again. So we would expect to happen that the first mint succeeds and the second one fails. So after we run this emulator trace, we should end up with 555 tokens, not twice as much. So let's check that out against my solution in the REPL. If I execute the emulator trace, we see that indeed this wallet ends up with 555 tokens. And if I scroll up a bit, I get to slot 110 and I see this log message deadline passed. So this is as expected. As second homework, I want you to slightly modify the NFT contract that I demonstrated by making the token name fixed and just fixing it to the empty byte string. So we don't need the token name as parameter any longer. We just need the UTXO that's supposed to be consumed. So I want you to implement this and also the corresponding minting contract, which you can just adapt from the one we had in the NFT module. I also provide a test emulator trace where I just activate the contract for wallets 1 and 2 and then call the mint endpoint. And if we try this out in the REPL, it works as expected. So we get the two minting transactions, and wallet 1 and wallet 2 end up with a shining new NFT, but it's a different one. The two are distinct because the currency symbols are different. And you see the token name in both cases is the empty byte string.